In this example, we are given a picture and we're told that there's a hot air balloon basket 300 feet above the ground, and the pilot, someone inside, is observing a stadium 2,200 feet away, but that's measured on the diagonal here. All right, and we are asked to find the angle of depression. The angle of depression is this angle made from the horizontal downward, in this case because we're looking from above downward. And we want to try to find this angle. So the first thing that we should do is try to get this angle inside of our triangle. All right, and one way to do that is to notice that in this picture, these two lines are parallel, and this is a transversal, right? And so just by transversal properties, this angle right here must be the angle alpha. And so now this is the angle alpha in a right triangle. And at this point we can see that this is the opposite side of that angle. And that's O, not 0, but O. And the length that was measured that we know, this is the hypotenuse. All right, and so right now, the thing that we want to know is the angle, and we can see for sure here we've got opposite, we've got hypotenuse. This should ring a bell. We should use the sine function, right? And so here we have a sine of our angle alpha must be equal to always opposite over hypotenuse. Okay, and we want to find alpha, so we'll have to talk about that in a second. But right now we have sine of alpha equals opposite over hypotenuse. We can compute that though, right? So we've got 300 feet divided by 2,200 feet. And it's always important when you're given units to make sure that they are the same, because they have to cancel, right? And they do. In this case, they do cancel. And so that's good. So those are canceling, and a lot more cancels here actually, because these both have a factor of like 100 that can cancel. And what we know now then is that the sine of our angle alpha that we want to know is 3 over 22. So 3/22. That's the sine of this angle alpha. Now somehow we have to get the angle alpha out of here. Well, what can we do? We need to, this sine is a function, right? You can't divide by the sine function or anything like that. So we need to try to get rid of this. We can't just get rid of it though. So instead what we can do is we can apply what's called the inverse function of sine. It's called the arcsine function for reasons that have to do with circles. But if we apply the sine inverse right here, and we'll see there's a button for this on your calculator, the sine inverse to both sides, then on the left-hand side what happens is that these two cancel each other, and now we have the alpha, this angle, is equal to the inverse sine, or the arc sine, of 3/22. Another name for this function, like I said, is the arc sine. And I think that's the way that we're going to want to put it in GeoGebra. So let's move over to GeoGebra now. And here's the GeoGebra calculator suite. Our ratio was, I already forgot, 3 over 22, right? It's 3 over 22. So there's a couple things we can do in GeoGebra. We can say, we can define this thing. We can just say like b equals 3 over 22. Okay. Enter. It goes to the next line. So this gives us an approximation. And now we want to do the arc sine of b, right? So we can say a for alpha is equal to the arc sine. Notice that it's got a function for arc sine, so that's exactly right. Arc sine of, my keyboard is slow here, arc sine of b, and there we go. It gives us the answer, and it tells us that the answer is in degrees, and that's very important because there's more than one way to measure angles. Well, one way is in degrees, and one way is in something called radians. In this course, we are not studying radians, so you don't have to worry about radians. So it's very important though that it's in degrees. So there we go. That's going to be our answer then, 7.8. I'm going to round it to a tenth there. So 7.8 degrees is going to be our angle of depression. But let's try to compute this one more time. Notice that it changed, even though I wrote arc sine, it changed it to this first symbol that I wrote, right? Sine inverse. So if you start typing sine and you want the inverse, it doesn't really work, right? So the button on your calculator might say sine inverse like here, like right here. sine inverse. But to type it in GeoGebra, if you're going to use GeoGebra, you need to do arcsine. Okay, and there's all kinds of different options here. Just pick arcsine. This is arcsine degrees, but arcsine gave us the answer in degrees anyway. Okay, so arcsine d is probably degrees. But anyway, so this is how we can use GeoGebra as a calculator. Again, our answer, though, we need to finish off our question here. So our answer is that the angle of depression is going to be 7.8 degrees, about, right? So we go back over here. Notice that I cut off some digits there, right? I rounded it, so I'm going to use a squiggle for approximate, but 7.8 degrees. That's the angle of depression that the person in the balloon has to look down at to see the stadium.